Alright, so let's continue 10.4. Well, actually, sorry. Let's continue 10.4, which is shifted conics. Well, we do not have hyperbola here. I'm sorry. So this is 10.4, shifted conics. Okay. Let's share the dust though. This is the 10.4. I don't even find it. Got it. So it's this one. Yeah. And two. Let's continue this. So determine the type of conic and if it is not a degenerate. So this is where we stopped yesterday. So Alex had a question, why is this no graph? But do you remember why? Because this is a positive, cannot be equal to negative number. Yes, that's right. Yeah, so let's continue. Number 2. Okay. What about if I have x minus 4 squared over 8 plus y plus 1 squared over 2 is equal to 1? Can you tell me what type of conic it is? Ellipse? Okay, good. Do we know the center? 4, negative 1. Yes. Good. If I ask you to find the vertices, foci, and everything, should we do this, or you guys are okay? Do this? Yeah. Okay. So what about the everything for ellipse, foci, eccentricity, those things? So should we do this? Okay. So this is for you, right? All right. So we usually start with scratch. Well, this is I'm glad we do this because it will be a little different. I'm going to make it a little bigger. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Okay, so the center is 4, 1, which is here. All right. And then how many units do I go up and down, or left and right? So left, right, how many? So A, what is A? Square root of 8, which is 2 square root of 2, which is approximately what? What is 2 square root of 2? 2.8? 2.9? Is it 2.8? 2.8. Yes. Now B is square root of 2, which is approximately 1.4. Right? So you start with 4, negative 1. You go up 2.8. So 1. Oh, you go left and right 2.8. Oh, I need to draw more here. Oh, I guess it has to be longer. Okay, so 1, 2, 2.8 is around here. And then 1, 2, 2.8 is around here. How do I label this? This is 4 plus 2 square root of 2, negative 1. And what about this? This is 4 minus 2 square root of 2, negative 1. So these are the coordinates of the vertices. And how many units do I go up and down? 1.4. So 1.4, so it's just less than half. So 1.4, 1.4. So this is 4 comma, negative 1 minus square root of 2. And this is 4 comma, negative 1 plus square root of 2. Alright, so here is your ellipse, sort of 1, 2. Right? So let's write down the vertices. So vertices is 4 plus or minus 2 square root of 2 comma negative 1. And also 4 comma negative 1 plus or minus square root of 2. Those are our vertices. What about the foci? For ellipse, what is the foci? C square is equal to, which one's bigger now? A squared minus b squared. So c squared is equal to 8 minus 2, which is equal to 6. So c is plus or minus square root of 6. Oh, usually we don't put plus or minus, just square root of 6, right? So where is your foci now? So if I have to graph my foci, where will it be? Yes, so it's going to be somewhere here. So square root of 6 is approximately what? Oh, 1.4 also? So it's the same as square root of 2.4, yes. 2.4. So from here, I'm going to go 2.4. So 1, 2, oh, it's very close to the, right? And then here, this will be very close to the other one. All right, so what is the coordinate of the foci? 4 plus or minus square root of 6, comma, negative 1. Yes, good. So remember, we don't memorize anything. H plus or minus, H comma K plus or minus A, something like that, right? We're just doing it from the graphs. Are we okay so far? Eccentricity, what is the eccentricity? Yes, E is equal to C over A, so square root of 6 divided by square root of 8, so this is square root of 3 over 4, right? So square root of 3 over 4, which is square root of 3 over 2. Oops. Square root of 3 over 2. All right. Yep. So this is an ellipse. Now, what about the next one? When you're done. So I'll do it when you're done. Finish? Or maybe let me write it down. So number 3, what about if we have x squared minus 4y squared minus 2x plus 16y is equal to 20? What would you do here? So possible, what type of conic? Which one? Why? Yes. So if it's not degenerate, then this is a hyperbola. So that's what we're going to see, if it is degenerate or not, right? How do you know this is a candidate for hyperbola? Yes, because the coefficient of x squared and y squared have opposite signs. Yes, that's why. So if this were not a degenerate, then this would be a hyperbola. All right, so we need to complete the squares as usual. Now, let's complete the squares. So, x squared minus 2x minus, what am I factoring out? 4, y squared minus 4y equals to 20. So x squared minus 2x, what am I adding? Plus 1, both sides? This is real 1, right? Y squared minus 4y, what am I adding? What is it? 4. Okay, is this a real 4 or fake 4? Okay, so this is supposed to be negative 16, so I add negative 16 to the other side. Right? Good. Now let's write down the binomial square. So this is x minus 1 square minus 4 times y minus 2 square is equal to, what is it, 15? 5? All right. So what am I going to do now? Divide by 5? Yes. So my equation is x minus 1 squared over 5 minus y minus 2 squared over 5 over 4 is equal to 1. Yeah. So look at the middle. We want something on the bottom so we know what b is. Okay. All right. So what type of conic is this? What is it? Hyperbola? Vertical, horizontal?
Horizontal.
Horizontal. Yes. Good. Can we know the center?
1, 2.
Yes. All right. So your center is 1, 2. That's right. Now, let's graph it first. So we know where the vertices are. So we're not going to, what is it called? Memorize, right? Okay, so why am I going for this? Hold on. So 1, 2. So 1, 2 is right here. This is my center. How many units do I go left and right? So vertices. A, what is A? B, what is B? A is square root of 5, approximately one coin. What is square root of 5? 2.2, approximately. Okay. B is square root of 5 over 4, which is square root of 5 over 2, which is 1.1 then, right? All right. So let's see, center at 1, 2, go left and right 2, 2. So 1, 2, 2, 2, and then 1, 2. Oh, sorry. 1, 2. Yeah. 1, 2. Oh, why is it so big? 1, 2. Okay, here. Oh, so the unit is a little bit bigger on the right side. 1, 2, 2. All right. Same side? Okay. And let's label this. So this is what? One plus square root of 5, comma 2. This is, what about this? 1 minus square root of 5, comma 2. How about the up and down? Oh, so you go up 1, 1 and go down 1, 1. All right. So this is 1, 2 minus square root of plus square root of 5 over 2. And this is 1, 2 minus square root of 5 over 2. All right. So are we drawing ellipse here? What are we drawing? Rectangle, right? This is a hyperbola. All right, then draw the asymptotes. All right. Now, how do I draw my hyperbola? I drew my rectangles and my asymptotes, but how do I actually draw my hyperbola? Any idea? Yes, we use the two vertices. You're right. It's horizontal, right? Yes. So we will use these two vertices, and then it's going to get closer and closer to the asymptotes, but not touch. All right. Yes, that's my hyperbola. Then, so what are the coordinates of the vertices?
1 plus or minus the square root of 5, 2.
Yes. So this is vertices.
1, 2 plus or minus the square root of 5, 2.
Yes. And the foci. So for hyperbola, what is the formula? B square plus B square. So 5 plus 5 over 4. So what is this? This is 25 over 4. So C is equal to 5 over 2. Yes. All right. So 5 over 2. So where is it? Here? On the axis? Yes. So this is the C is so 2.5. So your C is somewhere here. Your foci. So what are the coordinates of foci? Uh, 1 plus 2.5 is 3,5, right? 3.5, 2. And then 1 minus 2.5 is negative 1.5. Is that right? Yeah. Okay. So eccentricity. Oh no, asymptotes. Y is equal to plus or minus b over ax. But it's not y, it is what? Y minus 2, yes, and x minus 1, yes. So y minus 2 is equal to plus or minus b over a. What is b over a? Oh, square root of 5 over 2 divided by square root of 5. So x minus 1. So what is square root of 5 over 2 divided by square root of 5? 1 over 2, right? Finish. Okay, I think there are some that I calculate fast, but can I show you anything? Yes. Okay, which one? Here? This part? Well, yeah, you can. The coefficient on top should be 1. So if you have a 4, you have to bring it down. So let me see how I could explain that. So basically what you want to do is put all the number here, okay, and not have anything here. So so this is multiplying by 4 is the same as the how do I say that? So you're just dividing 5 divided by whatever this one is. Like this is 5 divided by 1. This is 5 divided by 4. That's how you get 5 over 4. Yeah. So because 4 over 5, if you see this, this is 4 over 5, right? This is equal to 1 divided by 5 over 4. Yeah. So you have to divide whatever number here by whatever number here, and then you have a 1 on top. Good question. Yes. So basically, this is what we're trying to do here. When I have 5 over 4 on the bottom, so before we have 4 over 5, so you want all the numbers to be on the bottom and you want to have 1 on top, so 4 over 5 is equivalent to 1 divided by 5 over 4. So just divide whatever number here by whatever the number we have over there. Yeah? Okay. Yeah, I know. I should have explained a little bit more about it. Thank you for your question. I think a lot of people will ask the same thing. But this is it clear now? Yeah, so 4 over 5 is equal to 1 divided by 5 over 4. Yeah. Good. And other questions? Are we okay? This one is okay? Square root of 5 over 2 divided by square root of 5 is equal to half. That's okay with you? Yes? Okay, good. So no questions. We're good. Now last one. Last one before we move on to chapter 11. So number 4, what about these? We have 3x squared plus 4y squared minus 6x minus 24y plus 39 is equal to 0. So basically these questions are only asking what type of conic, but we did more. Yeah. We found the center, we found the vertices, we found the foci, we found the asymptotes, if it's hyperbola. But in general, this question is just asking you, oh, what type of conic it is, if it's not degenerate. So if the question is only asking for what type of conics, we have to do all those things that we did? No. Yeah. So let's see what happens here. Maybe we don't have to do it this time. So what am I supposed to do now if we want to find out what type of conics? Complete the squares again? Yes. Like last time, you're right. And if this were a conic, what would it be? What is the possibility? If this were a conic, what would it be? Ellipse? Yes. Why? Same sign of x squared and y squared. Would it be possible that this is a parabola? No, why not? You have x squared and y squared. Parabola only has either x squared or y squared, but not both. Right? Good. So this is an ellipse. So let's complete the square and just see if this is degenerate or a good ellipse. So this is x squared minus 2x plus 4y squared minus 6y. Okay, good. All right. So what am I adding here? Plus 1 and, oh, negative 39. Plus 3, right? And what am I adding here? 9. And what am I adding here? 36. Okay, good. So this is 3 times x minus 1 squared plus 4 times y minus 3 squared is equal to 0. Oh, okay. What type of conic is this? Is it possible? Is it an ellipse? No, why not? For ellipse, it has to equal to a number here, and then you can divide so that they equal to 1. So this is a degenerate, right? But what is the graph? What is the graph? Well, if you know degenerate is good, but the graph is a point. It is at 1, 3. So your graph, when you graph this is not a conic, it's just a point. So when you graph this equation, it's just a point, which is 1, 3. 1, 2, 3. So it's just this point right here. So it's not an ellipse, right? It's a point, 1, 3. That's it. Yeah, the distance from 1, 3 and is 0. So that's it. We're done. This doesn't have a graph. It's only a point. Are we okay so far? You could tell if this is an ellipse, parabola, degenerate, or circles, hyperbola. Yes. Okay. Good. Now, I'm done with 10.4. Now, 10.5, I think we did 10.5 because we talk about substitution and elimination for nonlinear. Did we? Did we do in 9.1 or 9.2? I cannot remember. Did we talk about nonlinear equations? We did, right? Do you want to do 2 examples before we start 11? Okay, good. Yeah, we could do that, and then we want to start 11, though. Yeah. Okay, so let's save this, and then we will start 10.5, 2 examples, because we did those. I don't know why it's been repeated. Okay. All right, so close this, and let's start. Oh, we're done with not 10.3, but 10.4, shifted conics. So we're going to review systems of nonlinear equations. All right. 10.5, systems of nonlinear equations. Is it nonlinear equations or nonlinear inequalities? Give me a second. You have the book, Chow? Is it nonlinear equations or nonlinear inequalities? Yes. Rotation of axis? Oh, we don't discuss that. That's for trigonometry. It uses cosine and sine. Hold on. See what to calculate. Oh, basically we're done then. No. No. We are done with chapter 10. So, yeah, we're done. We graph systems of inequality, right? No, so we should start 11.1. Yeah. Ah, okay. So, axis of rotation of axis, yes. So for some reason I put systems of nonlinear equations. I wonder why. All right. So anyway, you guys don't want to have a test tomorrow, do you? When would you like to have a test? Did we set it up for Monday?
Yeah.
Okay, so it's just going to be chapter 10? Okay, so what I'd like you to do is look at the sample tests. What number? 1 to 43, right? There are some word problems that I would like to discuss, so on Thursday we will discuss them. Okay, so now I'm going to go to chapter 11. Should we include chapter 11 on your test? Today is what, Tuesday? 11.1 maybe, or 11.2? No? It's sequence and series. No? Let's see then. Let's see, because the following week is the last week, right? Yeah, so so we may or may not have a test for chapter 11. Probably not. Oh, maybe it's just like, oh. Let me stop again, and then let's record it again. So we are going to go to 11.1. Yeah. Yeah, because it's early. Today is Tuesday, right? Okay. How about we include 11.1 and 11.2? Yeah. Sequences and summation notation. Yeah. Okay, so that's fine. So this is 11.1, sequences and summation notation. So chapter 10 is how many sections? 4. And 1, 10, 2, 10, 3, 10, 4, finish. So let me include 11.1 and 11.2. So sequences and summation notation. Alright, so we're on the shape actually. Sequences and summation notation. Alright, what is sequence? So, okay. Let's start. What are sequences? Share the desktop. Okay, so 11.1 is sequences and summation notation. All right. So what is sequence? Sequences. All right. So sequence is a function. So you can think of function that computes an ordered list. All right. So for example of a sequence, 2, 4, 6, 8, 10. Can you guess the next one?
15.
15? What is it? 12, etc. Right? So this ellipsis says there's an end. Yes. So this is called A1. This is A2. This is A3. This is A4. And dot, dot, dot. This is AN. So N is equal to 1, 2, 3, 4, 5. So the first term is A1, and the second term is usually called A2, and the nth term is called AN. Okay. Good. And there are two types of sequence. So a finite sequence, so it's called finite sequence, stops. All right. And there is an infinite sequence. So if we don't say finite, then we assume it is infinite. Sequence goes on forever. So this is like 1, 5, 10, 15. Stops. Finish. Infinite sequence continues forever. So it's like 1, 3, 5, 7, 9, dot, 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 dot. So this ellipsis says it is still continuing and it doesn't stop. So if we say a sequence, it's infinite. All right, goes on forever. All right. So, for example, find the first 3 terms of a sequence. Okay. So, number 1. N is equal to n plus 1 over n plus 3. And then number 2, an is equal to negative 1 to the n divided by 2. So can you find the first 3 terms? So what is A1? N is 1, so 1 plus 1, 2 divided by 4, which is half. Yes. A2. So 2 plus 1, that is 3, divided by 2 plus 3, 5. Yes. So basically N is 1, N is 2. What about A3? 3 plus 1, 4, divided by 3 plus 3, 6. So this is 2/3. Yes. All right. Good. So the next one is AN is equal to -1 to the n over 2. Good. So let's answer this. What is A1? -1 to the first power over 2. Yes. What is A2? 1 over 2. What is A3? -1 over 2. Yeah. Yeah. Okay. So how do you change signs? So if you this is how you would change signs. So later on, you'll see if you need to change sign, then your formula will probably include -1 raised to the nth, or n plus 1, or something like that. Yeah? So this is not that bad, right? Okay, so let's continue. Yeah? Yeah. So 2 over 4, 3 over 5, 4 over 6. Yes. Okay. So the next one, maybe I'll do it here so you can still see it. So number 3, AN is equal to 1 over n. So can you find the first n terms? What are the first n terms? 1, and then 1 over 2, and then 1 over 3, 1 over 4, dot, 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 and the last one is 1 over 10. All right. So, and then dot, dot, dot. Now, AN, do you think when it continues, it will be close to 0? So we say that AN converges to 0 as n becomes large. So this is how we write it in short. Or in short, so if we want to write it in short, we write it like this. AN goes to 0 as n goes to infinity. Yeah? So AN, this just means AN converges to 0 as n goes to infinity. So this is called convergent sequence. So AN equals to 1 over n is a convergent sequence because it converges to 0. All right. So what about AN is equal to n? Can you list some of the terms of AN equals to n? 1, 2, 3, 4, blah, 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 right? Is it convergent? Does it converge to a number? What happens when n becomes large? What is AN? It's infinity, right? So this is called a divergent sequence. So it does not converge to a value when n is large. So this is a divergent sequence because it doesn't converge to a value. Okay. All right. So far so good with sequences? Easy so far? Okay. Now, let's talk about recursive sequence. So, recursive sequence. If you take programming classes, you will use a lot of recursive sequence. Did anybody take a programming class? No, not yet? Okay. So, recursive sequence. So, a recursive sequence is a sequence whose terms are defined as an expression involving the previous term. Or term. So, all right. So, example of recursive sequence. A1 is equal to -3 and AN is equal to 2 times N times AN plus 1, AN minus 1. If N is greater than 1. All right. Okay. So can we list 5 terms of this sequence? What is the 5 terms? A1 is -3. Okay. What is A2? Two times A1. What is A1? 2 times -3. So this is -12. Yes. What is A3? 2 times 3 times A2. Yes. So look at this. So A3 depends on A2. A2 depends on A1. Do you see it? Yes. So this is 2 times 3 times -12. So this is -72. Right? What is A4? 2 times 4 times A3. So 2 times 4 times -72. So 8 times -72. What is that? 586? -586? All right. So it's getting bigger. What about A5? 2 times 5 times A4. So 2 times 5 times -586. So this is -5860. Yeah. So this is example of a recursive sequence. All right. Do you remember the Fibonacci sequence? What is Fibonacci sequence? So this is examples of recursive sequence. So number 1. So number 2 is Fibonacci sequence. So what does Fibonacci sequence says? A1 is 2, A2 is 3, AN is equal to AN minus 1 plus AN minus 2 if n is greater than 2. All right. Do you remember Fibonacci sequence? No? Okay. So, can you list 5 terms of the Fibonacci sequence? List 5 terms. So basically, this is -3, -12, -72, -586, -5860. Right? On the previous one. Now, what about the Fibonacci? What is A1? Oh, A1 we know. What is A3? Yes, 2 plus 3. Yes. A2 plus A1. So 3 plus 2 is equal to 5. What is A4? A3 plus A2, which is equal to 8. Yes. A5? A4 plus A3, which is 13. Yes. So if you list them, 2, 3, 5, 8, 13, this is the list of 5 Fibonacci sequence. So what does the sequence do? It just adds this up. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. What do you think the next one would be? 21. The next one would be?
34.
Yes, etc. Right? So remember the Fibonacci sequence? No? Okay. Ah, okay. That's right. That's fine. Good. So we talk about recursive sequence and factorial symbol. Do you remember factorial symbol? Well, we will talk about the factorial symbol in a bit now. So we talk about recursive sequence, and in relation to recursive sequence, we will talk about factorial symbol. Yeah. Ready? Okay. So the next one is factorial symbol and factorial. So this is the definition, n factorial. Yeah. So 0 factorial is defined as 1. 1 factorial is defined as 1. And then n factorial is equal to n times n minus 1 times n minus 2 times dot 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 times 3 times 2 times 1. Or if I write it recursively, you could say this. 0 factorial is 1, 1 factorial is 1, and factorial is equal to n times n minus 1 factorial. If n is greater than 1. So you could define sequences recursively and regularly. Yeah. So let's do some calculation with factorials. What does it mean? And then we will see this again. What is 2 factorial? 2 times 1, which is 2. What is 5 factorial? 5 times 4 times 3 times 2 times 1, which is whatever it is. 120? Alright. What is 7 factorial? 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, so that's 120 times 42. What is that? That is 5040. Right? Okay. But you could also simplify. So this is evaluate. Number 1, number 2, number 3. What about if I want something like 20 factorial divided by 17 factorial? Well, this is a very big number, isn't it? Or if I want something 100 factorial divided by 99 factorial. So there is a trick here. So what we'll do is we will rewrite 20 factorial in terms of 17 factorial. So we will keep 17 factorial here. What is 17 factorial? 17 times 16 times 15 times 14, blah, 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 up to 3 to 1. How about 20 factorial? 20 times 19 times 18 times all the way. So I could write it like this. This is 20 times 19 times 18 times 17 factorial, right? So this is the trick. So this one cancel. So we just have to calculate these. What is it? 2 times 19 times 18. So 6840. All right. Finish. What about number 5? Do you know? Is it 1? Is it? Yes. So this is 100 times what? 99 factorial. Yes. So this is 100. Yeah. But your calculator should have a factorial symbol too. Yeah. So in my calculator, I will choose PRB. So it's in probability. So I will, if I want to just say, if I want, for example, 10 factorial. Okay. This is from my calculator. So then I have NPR, NCR, and then I just choose factorial. Oops, sorry. So I have to put my number first. So in my calculator, I put 10, and then I choose PRB, and then I choose my factorial. So 10 factorial is this. 3628800. So your calculator does have a factorial. So this is, so what I did was 10, and then I choose PRB, and then from PRB I have NPR, NCR, and then I choose factorial, and then it gives me that. This, do you have it? Does everybody have it? Yeah. Can you guys make sure you have it? If not, it's not a big deal, but you should have it. Yeah. Got it? Yes. So this is, what about, tell me what is 13 factorial? So it's going to be 13 for my calculator, PRB, and then I choose my factorial. That is, ooh, it's big. 6122270208000. That's from my calculator. Yeah. That's right. Got it? Yeah, but your calculator has it too. Yes. Now, we have 10 minutes. I will talk about series. Yeah. So 11.1 is short. Sure. Which one? This one? Okay. Are you talking about the second one or the first one?
I'm talking about this last one.
Fibonacci? Yeah, so you're adding this to get 5. You're adding this to get 8. 5 plus 8 is 13, right? So, yeah. 5 plus 8 is 13. 8 plus 13 is 21. And then 13 plus 21 is 34, etc. Yeah, that's Fibonacci sequence. Good. Now, let's talk about series. So B is series. What did we talk about before? What is it called? Sequence. So series we will add. Okay. So suppose, before we talk about what it means, let me give an example. So suppose I have a sequence. AN is equal to 1 over 2 to the n minus 1. Okay. So this is a sequence. Is this a sequence? Yes. So this is a sequence. So if I list my terms, what will this be? List my terms. The first one will be 1 over 1. The second term will be, so this is A1, A2, A3, A4, A5. So A1 is 1, A2 is 1/2, A3 is 1 over 4, A4 is 1 over 8, and then 1 over 16. Can we continue from here? What is it? 1 over 32, blah, blah, blah. All right? Okay. Now, series is like this. Series is summation. So S1 is 1. S2 is 1 plus half. S3 is 1 plus half plus 1/4. What is S4? One plus half plus 1/4 plus 1/8. So you get the idea of series, right? So what's the difference? For sequence, it's just each term. For series, it is you add them. Yeah. So if I fill this out, this is equals to 1, this is 3 over 2, and this is what? 7 over 4, and this is 15 over 8. All right. So these are this is A1, A2, A3, A4, A5, dot, dot, dot. But this is Sn is equal to S1 plus S2 plus S3 plus S4 plus Sn. Oh, what am I doing? I'm sorry. No, that's not right. This is A1 plus A2 plus A3 plus dot, dot, dot plus An. Okay. This is a finite series. Why is it called a finite series? It stops. Yes. Okay. Good. And then give a few space because I'm going to write a notation here in a little bit. And I also have an infinite series. So we're talking about finite series. And we also have an infinite series. What do you think an infinite series would be? A1 plus A2 plus A3 plus dot, dot, dot plus An plus dot, dot, dot. So it goes on forever. Yeah. All right. Okay. Now, finite series, I'm going to introduce a summation notation. This is called sigma. So this is called sigma. And then we go from I. So Sn is sigma. Well, I mean, it doesn't have to be that big, okay? This is a Greek capital letter sigma. I goes from 1 through n of ai. So this is called sigma. And what is I? I is the index of summation. Alright? Which is equal to A1 plus A2 plus dot 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 plus A. Now, can I write the as infinity using sigma? Yes, I can. So sigma, I goes from 1 through what? Infinity of ai, which is equal to A1 plus A2 plus A3 all the way to infinity. Alright, so the difference here, it stops, and this one goes to infinity, finite and infinite series. Alright, I'm not done with the summation, so because we have some summation rules, so tomorrow we will continue. Yeah. So what homework due on Wednesday? 10.4. Do you want to make this due on Wednesday? No? Yeah, I could close it on Sunday. Yeah, okay. But 10.4, up to 10.4 will be due on Wednesday. Yeah. All right. Okay, guys, tomorrow we will finish, yes. There's no 10.4? No, in the online, is there any, no 10.4? Really? What about 11? Do they have 11? Let's see, what do we do with 10.4?
No.
It's combined with 10.3? Oh, okay, then don't worry about 10.4 then. Yeah. So, but you guys know what it is, right? Ellipse, hyperbola, those things. Okay? Yes. Okay, good. All right, so we will continue with 11.1 tomorrow and finish 11.2 also tomorrow. Yeah? Okay. Okay, we will continue with 11.1 tomorrow. Yes?